Hi everyone, I'm Jess and I'm here today with my co-founders at Virescence. I'd like to start things off by talking about an industry that's highly embedded into American life. Public transit is crucial to our everyday lives, be it for commuting to work or traveling while living in a city. But even in an industry so vast, the innovation is very gradual. At Virescence, we identify three main challenges faced by public transit authorities, otherwise known as PTAs. First is the high cost of operation, particularly that of electricity. Each year in New York, the MTA spends $250 million to power their trains. Second, demand for these services is increasing as more people move to cities and become more environmentally conscious, but the infrastructure lacks the ability to meet these demands. And third, PTAs require a lot of energy to power their vehicles, which has a negative impact on the environment. Our lithium-ion capacitor provides a solution. Lithium-ion capacitors, or LICs, are situated between today's current standards for energy storage devices. We evaluate these devices based on their energy density, or storage capacity, and their power density, which is how fast they can charge and discharge energy. While lithium-ion batteries only have a high energy density, and supercapacitors only have a high power density, LICs deliver on both. This is due to the fact that they have one battery-style electrode and one supercapacitor-style electrode, a best of both worlds solution. Our LIC is even more unique due to its innovative green manufacturing process. It starts with corn cobs, a discarded bio-waste we collect from farmers. We turn these into activated carbon, a porous raw material key to the electrochemical processes that occur in our LICs. The LICs are built as small cells, and then thousands of them are put together into our final product, the integrated LIC unit. Circling back to transit authorities, our LIC unit is perfect for use in regenerative braking technology. Most subway cars have braking systems which allow them to generate energy when they come to a stop, but very few have storage systems connected to collect that energy and recycle it to power the train to its next stop. Some PTAs, like SEPTA, have attempted to use batteries as their storage system in the past, but these attempts were ultimately unsuccessful because batteries with a low power density can't charge fast enough to capture all of the energy available. Most of it would go to waste. Our LIC, with high energy and high power density, can capture this maximum amount of energy, which in turn allows PTAs to maximize the benefits they reap from regenerative braking. Addressing the three problems I mentioned earlier. First, by recycling energy with our LICs, PTAs can cut their electricity costs by up to 20%. Additionally, they can use the LICs to regulate their energy supply and demand and participate in lucrative grid servicing programs to offset operation costs. Second, putting the LICs on subway lines will increase the overall amount of power available, and this will allow PTAs to put more cars on each subway line to meet demand and increase revenue. And third, by recycling energy with our LICs, PTAs can drastically reduce their amount of electricity usage. Not only that, but they'll be doing so using a sustainable corncob-derived device. Now I'd like to hand things over to Shanti, who will tell you more about our market and our industry.
Thank you, Jessica. Our product is a part of a growing trend, and green transit technologies are becoming a symbol for environmental change. Local and national governments are using them as a political statement for their environmental policies. This has led to an increase in the demand for cleaner and more efficient public transportation, and Virescence is here to fill that gap. Taking a look at the lithium battery manufacturing industry for the EV sector, the revenue is set to increase at a rate of 4.2% to $6.9 billion by 2025. Currently, the two big shareholders in this industry are Panasonic and LG, having 57% and 10% of the market share respectively. Other small companies acquire the remaining 33%, and Virescence aims to capture a significant piece of it. Within this space, our direct competitors include Shaft Batteries, an industrial and military battery maker acquired by Total. Second, Maxwell Technologies, operating in the EV space, was recently acquired by Tesla. And lastly, A123 Systems that was acquired by the Wainwright Group in China. These three companies compete in the EV space, mostly focusing on cars and trains. Virescence will differentiate itself by focusing on the public transit sector specifically. We will become a successful industry player by focusing on three key drivers. First, the industry requires R&D, and with our continuous in-house R&D efforts, we provide a product that lowers production costs and has improved functionality. Second, companies like Scepter spend up to $50 million to acquire new technologies, and Virescence, with its increased safety offering, is therefore an attractive venture. Lastly, together with our green manufacturing process, Virescence is an ideal company for PTAs to invest in. Bashwi will now discuss our operations timeline and key activities.
Thank you. So we have already successfully built a small LIC, and our next step in R&D is to build a larger version of the LIC, a fully integrated unit that could be installed at a train station. After R&D phase 2, we will conduct the pilot program. The pilot program allows for us to perfect the customization process while manufacturing a custom LIC with our first customer. We will be at full-scale manufacturing by 2022, manufacturing units for multiple customers at a time. We also recognize the opportunity for selling activated carbon, but want to first establish the credibility of our corn cob-derived variant, as the barriers to entry in the activated carbon industry are high. In 2023, we will start selling this raw activated carbon. To launch and create our first LIC unit, we will need raw materials, including corn cobs and other chemical components, a manufacturing facility, and personnel. Our team will include 3 to 5 engineers for development of this novel manufacturing process, 1 sales representative, and 1 customer representative to manage the relationships with corn farmers and PTAs. We will also have 1 manager overseeing each contract, ensuring that the specifications are properly met. We will perform R&D to finalize the activated carbon creation and LIC production aspects. We also have to effectively manage the supply chain and B2B relationships. There are 2 specific aspects of our operational strategy that provide competitive advantages. The pickup of corn cobs from farms will be conducted daily using heuristic routing for optimal efficiency. The corn cobs will cost us $40 to $100 per acre. After acquiring the corn cobs, Virescence will store the corn cobs in facilities that are temperature and humidity controlled. With fresh corn cobs, due to the daily pickup and controlled storage facilities, the quality of our corn cobs will be preserved, ensuring that the activated carbon will have a high power density. This provides a competitive advantage compared to other forms of activated carbon. In terms of manufacturing, all activated carbon will be made in-house because it's a proprietary technology. For LIC units, our in-house pilot plant will have the capacity to create LICs for 1 contract at a time, providing flexibility to modify and perfect the specifications of the contract. Once the specifications have been finalized, the contract will be given to an outside manufacturer. This will give us the ability to start working on another contract in the in-house pilot plant. The use of subcontracting will allow for us to increase the output of LIC units while ensuring that each contract is given the proper attention. Ryan will now tell us more about the pilot program.
Thanks, Bashvi. We believe that the best method to gain our first customer is by subcontracting with an OEM. OEMs, or original equipment manufacturers, provide PTAs with their trains and new technology, and thus by subcontracting with them, we can leverage the relationship and establish a pilot program. The pilot program will last for approximately 3 to 6 months, and this will be a full product offering by installing our LIC unit into a train station. This allows us to collect data and demonstrate cost and electricity savings. We will use this pilot to prove our credibility and show that we are better than the status quo. Some examples of OEMs include General Motors and the Transportation Manufacturing Corporation. We believe that the pilot program will extend into an RFP, or request for a proposal. An RFP is a standard procurement method for PTAs, and this process is often marred by bureaucracy. Our finished pilot program and relationship with our OEM allows us to pursue RFPs more easily and better complete the process. Once we have built a reputation, most likely with several more completed OEM-aided RFP contracts, we will go independent, pursuing RFPs on our own without being a subcontractor. Other methods of acquiring customers involve networking with PTAs, specifically those with federal grants curated for sustainable technology. We will also attend transportation trade shows to display our technology, meet OEMs, and build relations with PTAs. Potential trade shows include the Secure Rail Show and the National Railroad Construction and Maintenance Conference. When we acquire an RFP, we will be selling LIC units to PTAs to place at subway stations. The total price of the equipment and the installation is $320,000, which accounts for 40,000 LIC cells per unit per station. This unit will connect directly with existing infrastructure and equip subways with regenerative braking. Our product also comes with a service and maintenance fee priced at $9,000 a year. The benefits of this service include a 24/7 rapid response service and a specialized engineering team dedicated to each PTA, like an account manager. Furthermore, this service provides in-person visits and detailed walkthroughs for any problem. Our goal is to make servicing as worry-free as possible and allow customers to resume their work. The overall message that we want our customers to know is this: we will save you money and provide you with green, environmentally conscious technology. Now, Praful will talk about the financial opportunities of Virescence.
Thank you, Ryan. So looking at our timeline again, we see our projected units sold over the next 5 years. 2021, which is our first year, is taken up primarily by R&D. In 2022, we expect our first subsidized sale through our pilot program. We will then hit peak operational scale in 2024 to 2025, when we will sell around 25 to 30 units. As Ryan mentioned earlier, a single unit sold to the PTAs will be priced at around $320K, and that leads to these projected revenues. In 2025, our revenues are conservatively estimated at $10 million, of which 12% are net earnings. This is generally in line with industry standards, and if anything, is slightly lower due to our in-house produced activated carbon, which reduces our cost of goods sold. Note that as per our projections, we expect to hit positive net earnings as quickly as 2023. Based on this forecasting, we've also identified periods of negative cash flow and are raising capital to cover our development costs until we reach our positive earnings in 2023. First, the founders will be raising $100K bootstrapped to get Virescence off the ground. In order to build the Virescence that we envision, we will seek a VC investment of $1.5 million for 32.5%. This will happen within the first month. In 1 year, we will seek a corporate investment of $2.3 million for 20% ownership. Each of these investments comes with 1 board seat each. The money raised in these rounds will primarily fund 2 large capital outlays that occur early on in our first 2 years. $320K will be set aside for our hybrid research and manufacturing facility, and that's going to be located in Iowa. Additionally, we'll also be hiring a team of 3 to 5 engineers with biochemistry backgrounds, for which we have another $300K budgeted. As we transition phases, a large allocation of our capital shifts towards hiring sales teams. By our 5th year, our largest cost center, about 1/3 of our revenues, goes to salaries. Given our earnings in the 5th year, we value Virescence at $25.3 million. We believe the best candidates to acquire Virescence are oil and gas companies. These companies are looking to invest in renewable energy, but they often need industrial-sized storage devices that make that technology economically feasible. A good example of this is in 2016, when Saft Batteries was acquired for $1.1 billion by Total. Virescence would fit this jigsaw perfectly. Through an exit, investors will realize sizable returns. We estimate the VC investor would earn around $6 million, and our corporate investor will earn around $5 million, with an ROI of 320 and 120% respectively. Regenerative braking technology allows PTAs to cut millions of dollars from their electricity bill and place more cars on each train to meet growing ridership demand. Our LIC's balance of high power and high energy density allows these PTAs to maximize their returns of their investments in regenerative braking. The PTAs also demonstrate their commitment to sustainable technologies. With experience working as entrepreneurs, researchers, and financial analysts, our team will work hard to expand our venture and build Virescence into an attractive asset. We believe in the promise of our corn cob-derived LIC as a sustainable and technologically superior device. Virescence. Spare the watt, save a lot. Thank you. We will now take any questions.